I'm Bob Vila. Welcome to the show. We've got a project underway here in Melrose, Mass, where we're refinishing a basement space. We'll show you some of the plumbing work we're doing down there, including how the PEX tubing gets run around. Also, basement systems, part of the waterproofing involves putting in a perimeter drainage system. Also, we'll be installing a whole house water heater from Rinnai. Stick around. When you're remodeling a basement space, one of the first things that you want to keep in mind is that you want it to be a dry living area. So last week we started looking at some of the problems this house has. Water infiltration from the exterior is something that is a common occurrence when you have gutters, and when those gutters get dirty or when the conductor pipes get clogged, you have water logging the soil around the house. So we've got water chutes that have been installed at the base, at the bottom of each one of these conductor pipes to get rid of that water and let it just flow away from the house. We've also got other smaller problems to deal with, which involve pointing up a chimney base and things like that. Then on the inside, we've already dug a perimeter trench around the whole slab of this area, and today we're going to be looking at some of the finishing touches that go in there. But behind me is a barrier, two types of barrier that were also installed last week. One of them in the finished base, which basically acts as a moisture barrier but also is reflective so that it helps conserve energy. And then this one in unfinished space, we're in the area that will be framed off for equipment such as the water heater and the furnace. This basically also keeps any moisture that tries to filter through the foundation on that side, and it'll actually drip down and into these channels. Now Larry Janesky's over here, and he's going to explain the rest of this installation. Larry, we're continuing with the what's this one called, the water guard?
The water guard, right.
Yeah. And so that is the conduit around the entire perimeter.
That's right.
What's he doing with the stone and stuff?
He's setting the water guard to elevation, and we backfill it with drainage stone to make sure that it's the proper elevation. It'll take all the water from the walls, from underneath the floor, and drain it all around to the sump.
Okay. So the crushed stone will hold it in place at the right level and pitch. What's this gizmo you've got right down here?
Yeah, this is called a water guard port, and we put this in for a couple of different reasons. One is it's an inspection port, so you can see what's going on inside the system afterwards, after this is all concreted up. But also in this basement, we're going to be putting in a dehumidification system, and it provides a good spot. If we knock this out, it provides a hole for the condensate line from the dehumidification.
So you can have a 3/4 inch line go right in there for the condensate.
Right.
Okay. Then let's talk about the most important component of the whole operation, I suppose, which is the sump.
Right. Yeah, this is going to be a triple safe sump system that we install here. And this has 3 pumps in it, so that if one pump ever fails, we have backup pumps to take the
water
risk
out of here.
That's right, so that there's no risk of flooding from pump failure.
So what you have here is a wonderful little model.
Yeah, this is a model of that triple safe sump system, and you can see there's 3 pumps. This is your first pump, it's AC operated. This is your secondary pump. This is an AC backup pump. So if this one ever fails, then this one will take over.
And those are both hardwired to the house electricity.
That's right.
Okay.
And in some basements, they get a lot of water. So if one pump can't keep up with the amount of water in a big, heavy rain, then both of these pumps will operate simultaneously to get over double the amount of water out.
But isn't the pipe, I mean, aren't you limited by the diameter of the pipe?
That's right, and that's why we have 2 different discharge pipes coming out of here.
Okay.
And run them both separately to the outside.
I see, okay.
Yep.
And then the third pump?
The third pump is a battery-operated backup pump. So if the power goes out, the water will rise to its operating range, and that will automatically pump the water out off a battery power supply.
Excellent. Okay, so we've got the lid on it, and we're just adding more crushed stone to secure it, but there's always going to be some standing water in that. Isn't that a problem?
Normally it would be, but this sump system has an airtight lid on it, so that pool of water that's sitting there all the time doesn't evaporate.
So it can't evaporate back in. All right.
Yeah, and we've also included an airtight floor drain in the sump lid. So this way, if there was a plumbing leak from any plumbing source in the house, it would run to this low spot and then run down this floor drain, which lets water down, but damp air cannot come up because it has a cup and a check ball underneath that floor drain.
So you've thought of everything.
We try.
What about if you run out of power and you go on battery power?
Well, that's important that the homeowner knows that they're on battery power. So this is the charger box and control box for the battery backup pump, and we're going to mount this on the wall up there. And there's a loud alarm that sounds off when the homeowner is on battery power to tell them, hey, you've got to restore these primary pumps before the battery goes dead.
Okay. It seems like you've thought about everything, but there's got to be some other potential problems down the line. I mean, you're taking all the water that collects here up and then through in between the ceiling joists to an outside location. What about issues of freezing?
Yeah, that's an important issue too, and we have the solution to that. They're called ice guard fittings, and we've mounted them outside already.
All right, so that the ice guard prevents any icing from occurring and forming all the way into the house.
Well, it doesn't prevent the discharge line from freezing underground outside, but what it does in the event that it does freeze, it has openings to allow the water to eject automatically out and away from the house, so you never get flooded because your discharge line from your sump pump is frozen.
Excellent. It's an ingenious system. Thanks very much, Larry.
Thank you.
All right. Once the waterproofing was completed, then we had to worry about the existing plumbing and the waste pipes and stuff. Had to move a lot of stuff so that we'd have head clearance. Al Leone gave us a hand with that, including the main stack here, which he actually had to replace.
The first step in removing the kitchen drain is to cut it into sections. That way we can take it out of the hangers and down from the ceiling. We need to replace this in order to get the new drains in, the equipment that we're putting in. That's called a soil pipe cutter, and it's made to cut cast iron pipe. There you go. We're just going to cut this old clamp.
There's a stereotype that union plumbers only do large projects, but actually Al's a small union contractor from Peabody, Massachusetts, who decided to go into business for himself. He's been working with his helper, Matthew Orlando, who's going through the plumbers and gas fitters local union number 12's apprentice training program in Boston. The chapter spends $4,500 a year to put each apprentice through a thorough 5-year training program, where they spend 2 nights a week learning about everything from bathrooms to hospital gas work. Here they've been doing a terrific job updating what was basically a plumbing museum.
And it's brittle, so it'll crack. The strength of the cast iron is really in its vertical holding weight. This is a 2-band clamp. The neoprene gasket is made of stainless steel. I'm using a torque wrench to apply the right amount of poundage to the clamp with 1 click or 2.
The way that these joints are held together, we use lead and oakum. And oakum is basically hemp that's been soaked in oil, and we pack it inside the joint and we pour hot lead over it, which makes the seal. The tool to pack it down inside the joint. This tool is called a joint runner, and what it does, it wraps around the joint and it keeps the lead from running out of the hub as you're pouring it. This ladle holds about 4 pounds of lead, and we melted a ladle full, and we packed half the joint with oakum, and the joint only took what it needed to fill.
Installing a clean out at the base of the stack, which will allow access if there should be a clog. These clamps work by having a neoprene sleeve to provide the seal and a stainless steel clamp to tighten it against the pipe. And in this case, a 4-inch by 2-inch Y, which will pick up the new kitchen drain. It'll be running alongside that wall.
Okay, we're going to use a 4-band clamp on the old work because the old piping is a little thicker, and that way we'll have a better seal in between the new pipe and the old one. We're going to demo these old brass water lines, and we're going to replace them with PEX tubing all the way up to the risers. And we're going to eliminate this this obsolete water hammer as well. It's no longer needed. First step is to drain the house down of any water, and then to cut the pipe into sections where we can take it down. This is the original brass tubing that was used when the house was built, and as you can see, it's very corroded and very thin, and it's always a good idea to get rid of it when you're doing any remodeling work, because you don't want this stuff breaking on you. We're running the new PEX water line to the connections, and we're going to pull it so we have enough to get over to where we need to go. We're going to assemble a bend support to hold the pipe in place.
The use of PEX throughout this job is making it easier to keep precious headroom and really cutting down on the time it takes to do things like relocate the laundry and update the old water lines.
Vila is a manufacturer of PEX systems. We manufacture 3 different kinds of PEX. PEXL for plumbing, PEXtron for heating, and last, FostaPEX. FostaPEX is a product with form stability. It can be used for both plumbing and heating. This product also is used in applications for radiant as well as baseboard heat. Today we're talking about the PEXL plumbing system, and the big advantage of our PEXL plumbing system with Vila is our connection system. Our connection is simple as we have the stainless steel ring with a sleeve with an eye hole in it. The eye hole is designed so that you can see that the pipe, the sleeve is all the way on the pipe. We then insert our fitting, which holds the sleeve in place. So this system can be dry fit and then attached later and pressed later.
There's a lot of new innovative products that make remodeling an old house easier from the plumbing perspective, and a lot of do-it-yourselfers like to tackle it, but most of the time you're better off hiring a master plumber. Okay, so we've got a water heater to talk about with Dan Driscoll, and Dan's an old friend. We've talked about these Rinnais before. This is for the whole house, right?
This is a whole house system, Bob. This is going to replace the tank heater that was in the house. This is size for a 3-bathroom household. So this will provide laundry, cooking, dishwasher, and bathing from multiple fixtures. It also has a feature, it's a cold start appliance, meaning it doesn't store water, it's very energy efficient.
Right. No, that's a very big deal in a small house, too, because here we're trying to capitalize on the basement space, and if you had to take up an additional 4 square feet with a big tank, that would, you know, be a waste. So this really can do that, though. I mean, you're talking 3 bathrooms, and this is a 3-bedroom house, I believe, so that you could have as many as 6 people needing to use showers and all that, and this can supply it.
This will allow the consumer to run multiple showers in the household at the same time indefinitely. Once we create flow, We're going to establish that flow and have that for a period of time, unlike a tank heater, which will run low on temperature.
Right, because if you, yeah, exactly. So, how does it do it? I mean, can we look in there to see the components?
Yep.
Because it's a 5.3 you were saying earlier.
That's the flow rate on the unit itself.
That's the actual flow rate, 5.3 gallons per minute.
Correct.
Yeah.
What we do is we measure when I will measure the water temperature on the inlet side. There's a controller here on the side that was mounted on the side of the unit, which the homeowner can set the water temperature at.
Can that be taken remotely and put in some other part of the house?
This could be mounted in a bathroom, in a laundry, or a kitchen, or a backsplash. Just hold that piece. I'll grab the other one. Pop the cover here.
So you could theoretically alter the temperature. For example, if you wanted it hotter or cooler, you could use that remote.
An application could be if we had children in a bathroom. I could drop the water temperature to a safe level where there would never be an issue of scalding.
Right. Ooh, they fit a lot of stuff in there, don't they?
Well, it's a little busy.
So the water feed, let's say the cold water's coming in. We've got to move the water service over to this location.
Right.
And then what happens in here?
What happens is the cold water feed makes up an IPS connection right here. You need flow in order to initiate the burn. So we need a half a gallon per minute in flow, which is about a 3/8 stream of water, very small volume of water. That would be established by opening a faucet or a bath spout or a shower valve. Once the water enters the unit, it's going to get picked up by a thermistor, which is a temperature sensor, and then also the volume of water. So it's measuring the volume of water and the temperature rise to what you've selected for an operating temperature. Then the burner makes an adjustment, the same way a carburetor would in a car.
Where's the fuel?
The fuel is on a gas fit right here, and this is our gas burner right here. It's below our heat exchanger.
Okay.
So the burner is below, the water travels through these pipes, through the heat exchanger, and this is our vent assembly, which goes to the outside for the flue gas.
Okay. So what about cold air intake?
We use a concentric vent, which is a 2-pass flue pipe, which allows us to bring combustion air in, it's sealed combustion, and exhaust through a center tube.
All right, so this is a sample of that, or this is the actual one?
This is the termination length that will be mounted to the outside. So our exhaust gas would be through this center tube, and our combustion air would come in through this OD. Now the PVC is zero clearance from combustible. So if I had a wood frame timber, I don't have to worry about setbacks. This piece here is what I would see on the outside of the building. About 2 inches goes to the weather. This is our exhaust port, and this is our inlet air.
It's so simple.
It's very compact.
And it's very, I mean, energy efficiency is a big deal. You're also saving money here, right?
Oh, this unit here, with a typical gas consumption, is about a 40% savings.
Wow.
Over electric, about 70%.
Over electric, it would be like 70%.
Yeah, depending on your kilowatt rate. But in this area, it's about 70%.
We're in New England here. It's not good. Yeah. Okay, thanks, Dan.
Thank you, Bob.
All right. Well, it's almost finished, but so are we. Next week, we'll be installing heating and ventilating and air conditioning equipment, as well as teaching you how to fix squeaky floors. Till then, I'm Bob Vila. Thanks for joining us.